In this podcast, we're going to talk about solutions. Remember that solutions are a homogeneous mixture where two or more substances are not chemically combined and cannot be distinguished from each other. There are two parts to every solution: the solute, which is a substance that is dissolved in solution, and the solvent, the substance that is used to dissolve the solute. Here's a cheesy animation to help you remember that the solute is dissolved into the solvent. Man, that's cheesy. One of the most important things to know about solutions is concentration. This is the amount of solute dissolved in an amount of solvent. Here comes another cheesy animation. Imagine if both of these containers have the same amount of solvent in them, and the one on the left has 4 particles of solute dissolved in it, and the one on the right has 2 particles of solute in it. The one on the left is more concentrated than the one on the right. Now we can make the one on the right more concentrated by either adding more solute or getting rid of some of the solvent. That will also raise the concentration. Because the amount of solvent has gone down, the ratio of solute to solvent has gone up. Here's another thing you should know about solutions. Like dissolves like is a classic phrase we use in chemistry. For example, polar solvents will only dissolve polar solutes and ionic solutes. They will not dissolve nonpolar solutes. Water, which is a polar solvent, will dissolve sugar, which is polar, and salt, which is ionic, but it will not dissolve oil, which is nonpolar. The same thing is true for nonpolar solvents. Like dissolves like. Oil would not dissolve salt, and it will not dissolve sugar, but it will dissolve gasoline, which is nonpolar. Now we move on to solubility. There is always a certain amount of a solute you can get into a certain amount of solvent, and that's what we call solubility. You can't just keep putting salt into water and think it's going to dissolve forever. And you'll notice that in the solubility curve that the y-axis has grams of solute per 100 grams of water, and on the x-axis is temperature in degrees Celsius. We'll have to keep both of these in mind whenever we perform a problem. The first problem: what mass of ammonium chloride could one dissolve in 60 grams of water at 40 degrees Celsius? So what we need to do is we need to find the line for ammonium chloride. There it is right there, and notice I pointed to the spot at 40 degrees Celsius. Well, what we do is we go over to the y-axis, we look at the mass of ammonium chloride we could dissolve at 40 degrees Celsius in 100 grams of water. It looks to be about 46 grams of solute. So what I do is I set up an equation. I can get 46 grams of ammonium chloride into 100 grams of water, and I set up a proportion where we want to see how many grams of ammonium chloride we can get into 60 grams of water. When I cross multiply and divide here, I get 27.6 grams of ammonium chloride can be dissolved into 60 grams of water. The second type of problem: if 50.0 grams of potassium nitrate was dissolved in 75.0 grams of water at 35 degrees Celsius, would the solution be unsaturated, saturated, or supersaturated? First, let's talk about what those 3 words mean. Unsaturated means you have less than the amount of solute that can be dissolved. Saturated means you have the exact amount of solute to be dissolved. And supersaturated is when you have more than the natural amount of solute that can be dissolved into a solvent. Okay, to solve this problem, we're going to zoom in on the graph. Keep in mind where the line for the potassium nitrate is. 50 grams into 75 grams. Let's set up a proportion so we can compare it to the graph. 50 grams into 75 grams is equal to X grams of potassium nitrate into 100 grams. This way we'll be able to solve for how many grams of potassium nitrate can be dissolved into 100 grams of water and compare it to the chart. We find out that there's 66.7 grams of potassium nitrate that can be dissolved into 100 grams of water. Now we can compare it to the chart. Remember, we're talking about 35 degrees Celsius. So I go up to 35 degrees Celsius and I go up to 66.7 grams of potassium nitrate, and I compare it to the line that we have on our chart. That looks like the dot that we form is above the line, so that means that it is supersaturated. Had that dot been right on the line at that temperature, it would have been considered saturated because we would have had the exact amount of solute dissolved into the solvent. Had it been below the line, it would have been considered unsaturated. Since it is above the line, we consider it to have more solute than what should be dissolved in a certain amount of solvent, and we consider that supersaturated.